All right, so welcome to your science, everybody. So if you were absent for the temperature ranges lab, here we go. The thing about this lab is that it really is the same as this lab in a very real way. If you can say, I did this in a laboratory, right? I had a beaker of sand and a beaker of water. I looked at how they heated and they cooled. Then you can say for this one, all I'm going to do is look at two different cities. I'm going to look at one city that has a lot of water around it, a coastal city, and I'm going to look at another city that does not. We're going to call it the continental city, the one that's off in the Midwest somewhere. All right, when the sunlight hits this versus when the sunlight hits Boston over here, there's a difference, right? And it's really, your lab mimics that difference. That's what we're looking for. Just like the beaker of sand, that'd be the continental one, the beaker of water one. Yeah, there's some land there, but there's a huge ocean there as well. So if we look at those two, can we compare the temperature ranges? Okay? Beautiful. So let's circle that word, because that really is a critical word here. I don't want to see, well, it's just not the correct answer in this lab to say city XYZ is hotter, because maybe it is for part of the year, but there's another part of the year where it's going to be colder. So it really is more about the range, which is the difference, which means subtract if you got to do some math, from high to low. So you're going to look at monthly temperatures. On average. So what's the average January, what's the average February, what's the average March, and so on. And how different are they from the hottest one to the coldest one is really the meat and potatoes of this thing. Okay? And it really is just like this lab. Or really, we'll say it right here, just like going to the beach, just on a longer scale. This experiment takes place over a year. So in this lab, if your numbers worked, which they did for most people, the sand went up by a lot and down by a lot, so it had a larger temperature range. Where water didn't go up that much and also didn't come down that much, has a smaller temperature range. Okay? You're going to see that. I mean, this lab works every time. And as just an example, I didn't live in this city, but I lived up here for a year. And I knew it was going to be cold, but it was very, very, very cold in the winter. Like from Thanksgiving to St. Patty's Day, frozen the whole entire time. Wind chills -30, -40, we'd still have school. And that's a function, and I know there's a lot of little lakes here, but they're all real shallow. That's a function of it being far from any body of water. And then also in the summertime, it got to be really hot. So that's why I can't say Minneapolis is colder. It is colder in the winter, but it's not colder in the summer. So we got to think more of this in terms of that range, that difference between the two. That will get us our answers. And again, in real life, you know this. You go to the beach, you step on the sand that's been in the sun, and you say, wow, that's hot. But then if you go back at night, if you go to the beach at night, is the sand still that hot? It's not, right? That would be very weird if it felt that way. So it goes way up and it comes way down. That is what a larger range is. Whereas the water, you go running into the water because your feet are hot. It'd be very bizarre if it was as hot as the sand, right? It doesn't. It comes up just a little bit and goes back down a little bit. It has a smaller temperature range. As evidenced by Lake Ontario right now. We've had some below freezing temperatures here in town. Lake Ontario didn't freeze. The land can drop off quickly, but the water goes very, very, very slowly. All right, now what this is, it's already filled in, but this all has to do with this. This is a property of materials that may feel a little bit weird. It's called specific heat. It's a vocab word we got to start to get down. And what it is, it's a measure of, the label really tells us, though it doesn't make it simple to understand. It's joules per gram times degree C. In other words, how much energy is needed for a temperature change. Some things heat up easier than others is really what we're saying with this chart. And water is the highest thing on the chart. Water has a very high value, so it needs a lot of energy to get it to warm up. Whereas the things that like land is made out of needs less energy to get it to heat up. So there's the premise of the lab right there. If you take a coastal city, put the sun on it, since water needs a lot of energy to get it to heat up, it's not going to heat up as much. So the city will stay cooler in the summer. Whereas this city just, boom, takes off like the sand at the beach. Go to winter, water also, since it cooled up warmed up very slowly. It's also going to cool down very slowly. So it's going to like hold onto some heat energy, keeping the city a little bit warmer in the wintertime. Whereas these guys over here, it just plummets. There's no like source to hold that heat with the big body of water like we have here. This even works with Lake Ontario. Around Pulaski will be a little bit warmer in the winter than going, say, 20 miles inland. Even going to Lake Syracuse or up to like Lowville, those are going to be colder because that lake keeps us a little bit warm. Okay. Wrapping up, one of the important parts of this lab was controlling your variables, right? We wanted to make sure that each one of these two beakers was the same distance from the lamp so that they got the same amount of energy. So we put the same amount of energy into each, and we saw how they reacted differently to that amount of energy. So how can I control that with two cities in real life? Well, since I've studied my earth science during marking period 1, I know that if you have two cities on the same latitude, they receive this, they basically have the identical experience with sun. So you're going to have the same sun angle. So how high does it get in the sky, which is a function of how well it heats your land. You're going to have the same duration, which is a fancy pants word for how long does it take. So from sunrise to sunset is the same across a whole entire latitude. Even the like compass direction that it specifically rises and specifically sets will be the same on the same latitude, right? The time zones are different, the longitudes are different, but when the sun comes up, it goes down the same amount of time later, right? So picking the same latitude, I feel like I'm saying this in a more wordy way than I need to, but picking the same latitude is the same concept as putting these two the same distance away from the lamp. It controls all the variables. It makes sure the input of energy to those two is equal. So like these two that I picked are on the same latitude, close enough. Sioux City, Iowa, maybe you take these, maybe you don't. And then over to, this one was Boston. So since those two were on close enough to the same latitude, they'll get the same amount of sun throughout the course of the day. Did I say that enough times? So what's your job? You're going to click whichever period that you belong with us. I know I forgot to change your name. I know you're not Beluga Whale and you're not Kelvin anymore. My bad. It's Hawaii Hotspot and Sandwich. But whatever. Click period 7 or period 9. You're going to get a sheet that looks like this, which has everybody's initials on it already. For these are the people that were here on Friday that did it. Pick an unclaimed box, and those will be your cities, like the ones that I popped up on that Google Earth thing. Right, the coastal is Boston, the continental is Sioux City. So whoever PC is, that is the two cities that they did in their lab. You take an unclaimed box, don't do the same one with a partner if you're sitting right next to them, and you're good to go. From there, put the names of those two cities in here. The coastal city goes there, the continental city goes there, and we're looking for what is the average temperature in January and in February and in March. This website has all of that info. If you click that, and I don't know, let's say New York's one of them. This website has ads, I apologize.